Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So the topic that we will discuss about it is the electrical conductance. So the word electrical, it is related to the electricity, and the word conductance mean to conduct or to move it. So the ability of metals to conduct electricity, this is known as the electrical conductance. So the metals have the most probably ability to conduct electricity. Now, what are the main reasons that metals can conduct electricity? Before to have a look on the reason, we must have the most conductive elements at 20 degrees Celsius. So these are the examples of the metals that can conduct electricity at 20 degrees Celsius temperature. So first one we have silver, then we have copper, we have gold, we have aluminium, calcium, tungsten, we have zinc, cobalt, nickel, and we have lithium. All these elements are basically metals and they are known as most conductive metals. Now, what is the reason behind that the metals can conduct electricity? Because they have free electrons. And these free electrons are basically present in their valence shell and they can lose these electrons easily. So that's why these electrons then come into the solid lattice and then they just start to conduct the electricity. So this is the main reason of electrical conductance of the elements. So then we have the trend of electrical conductance across period and group. When we move from left to right, as we see that in the first group we have 1A sodium metal, then we have magnesium and aluminium. These metals have their giant metallic lattice, it means their structure is large. On the other hand, the silicon, it is having giant molecular structure on, but it is a poor conductor. And sodium, magnesium, and aluminium, as these are the metals, and they are good conductors of electric. Then we just move on to the known metals, the phosphorus, sulfur, chlorine, and argon. All these are known metals and they are known as the known conductors because they do not have free electrons. On the other hand, they just require the electron to complete their valence shell. So that's why they are known conductors or known conductors of heat as well as the known conductors of electricity. When we have a simple look on their relative conductivity, along x-axis there are the atomic number and along y-axis we have the relative electrical conductivity. So first one we have magnesium and sodium and then we have magnesium. So there is a little bit change because it is alkali metals from group 1A and magnesium is alkaline earth metals from group 2A. Then we move to the aluminium 3. Now what is the reason? Because sodium has just one electron in its valence shell. Magnesium can lose two electrons. On the other hand, aluminium it can lose three electrons. So its electrical conductivity is high among alkali and alkaline earth metals. And then moving down, silicon, phosphorus, sulfur, chlorine, and argon. All these are known metals and they are known conductor for electricity. So that's why their electrical conductivity is almost no more or zero. The reason is only they do not have free electrons. So that's why they are known conductors of electricity. And when we move from left to right, as you can see that the electrical conductivity decreases in the period because we have metals and then we have non-metals. And metals are conductors of electricity, while on the other hand, the non-metals are non-conductors of heat as well as electricity. Then we have the trend along group. So the group 1A, these elements are known as alkali metals. Moving down the group, you can see that all these elements have one electron in their valence shell. But as we are moving down, the things that are affecting it is their atomic size. The atomic size of an atom increases when we move down the group. So the valence shell is moving away from the nucleus. As the valence shell is moving away from the nucleus, then to lose the electrons, it will be easier for the atoms. In turn, their electrical conductivity increases as we move down the group. So the reason is because their conductivity is directly proportional to their size. When we move down, size increases. In turn, the electrical conductivity of alkali metals also increases. On the other hand, we can also write their trend as lithium is less electrical conductivity than sodium, and sodium has having less than potassium, potassium having less than rubidium, it is having less than cesium, and then cesium is having less than francesium. So the most conductivity will be of francesium and the least conductivity of the lithium will be in the alkaline earth metals. On the other hand, we also have the group 2 elements. These elements are known as alkaline earth metals, and here we have beryllium, magnesium, calcium, beryllium, magnesium, calcium, strontium, barium, and radium. All these are known as alkaline earth metals, and these alkaline earth metals can also conduct electricity, and their conductivity increases as we move down the group, and the reason is same, their atomic size increases. Now we will discuss about some important metals. These metals are mainly known as the coinage metals. Now what is the meaning of this? The metals that are used for making the coins, and they are having their very important or importance in the industries. These are known as the coinage metals. So the coinage metals are of three types. The first one is copper, we have silver, and we have gold. It is known as aurum. So all these three metals are known as the coinage metals, and they are mainly used for the preparation of the coins. And their main properties, they are good conductors of heat as well as electricity. So they are considered as the conductors due to their free electrons present in their valence shell. So the coinage metals are also very important. On the other hand, when we have an example from the transition series of elements, when we have transition elements that are the group B elements in the periodic table, so we have many elements that are conductors and some are non-conductors. For example, if we have a carbon, it is having its two allotropic forms. The first one is diamond, and then it is having a graphite. When carbon is present in the diamond, then it is non-conductor, but on the other hand, when it is in the form of graphite, it is a conductor. So just the reason is that when it is in the form of diamond, it's all the atoms are bonded, but in the graphite, it is having just one free, we can see, that can move the electrons or unbonded electrons, and it can conduct the electricity. So this is all about today's lecture. I hope you guys understand, and if you have any queries, you may ask me about that. And the next topic that we will discuss, it is the hydration energy. For that time, you guys have a good day, and Allah Hafiz.